the question I asked you, is it possible to cross the vertical lattice? I mean, to cross the vertical asymptote? Is it possible? Yes or no? Never.
You said
No.
sometimes.
No. That's horizontal. Yeah. The vertical asymptote, the graph can never cross it, but horizontal is possible. So, you know what graph is it? Okay, so you want a sample. For example, if you have this graph right here, that graph is actually cross the horizontal asymptote. What is the horizontal asymptote here? You forgot how to find H8, yeah? Yeah, J. It is 0. You just find what value you want to make them undefined, remember? Remember? When x equal to 0, that's undefined, right? You divide by 0, you're going to have infinity. Infinity is the sign that's going to be horizontal asymptote. So here, HA is y equal to 0. But actually the graph actually crossed. Let me show you the picture of the graph. The graph crossed this multiple times, many times, until it's settled down to the 0.
I can hit it higher, trust me. I see a little crack in the mirror.
That's exactly why. If I use my notebooks no windows in the entire.
So here's the graph of it. Do you see that the graph crossed the HA multiple times? Here, you see that? Until when they get to the what is it?
Why are you using AI picture?
Until I think I clicked something. Until it settled down. It settled down to just like they go toward the horizontal asymptote. But in the beginning, it crossed the HA multiple times. Yeah? Because you use one hand, that's why. Yeah? Okay. Question, yes.
Basically, the horizontal axis,
You can't hear. Yeah.
is the x-axis.
Horizontal is the horizontal line, right?
Yeah.
But that means it's y equal to something, not x equal to something.
But like the horizontal asymptote can change. Like positions, like up, down.
What do you mean can change? They can cross? They can cross?
No, like it was like that. Like,
Yeah.
Cause okay.
Uh-huh.
Cause like okay, the horizontal asymptote here is this line, right?
Uh-huh.
That line. That
Yeah. Which line? Oh, use this one. Don't hit it again.
Okay.
Yeah, what line?
This line.
Yeah. Okay.
Why are you moving your head? Okay, this is the horizontal asymptote.
Right. Uh-huh.
Okay. But can the horizontal asymptote become like this
Yeah.
line or that line? Right?
Yes.
Okay.
Yes.
And the same for the vertical asymptote.
Yes, they can change. Depend on the function. Yes, depend on function. Yes. Mm-hmm. Any other questions? Yes. Can hear. Yeah.
Was the horizontal asymptote or just like sine x or cosine x?
You say again?
Just like what's the horizontal asymptote or just sine x or like cosine x or like tan x?
No. Actually, if you have something like this, what is the horizontal asymptote? Yeah. You can. Let me see. Oh, horizontal asymptote is when the bottom is 0, right? The bottom is 0. Remember when the top larger than, okay, no, this is not good symbol. Remember the last one?
The what?
If you have the top and you have the bottom,
Oh yeah.
remember if the degree are the same,
Oh yeah.
then the horizontal asymptote is
I remember now.
the coefficient of this. So it's going to be A over B. If the bottom is larger than the top, So like if the n is larger than n, what happened? You have that note?
It's over here. I'm finding it.
Okay, maybe when you find it, you memorize more. Find it. We have two cases. Okay, when the top larger than the bottom. I'm talking about degree. Okay, when the top equal the bottom, and when the top less than the bottom, what happened? What happened with the HA?
Oh, shit.
There is no.
You found it?
There's no.
Which one? No.
When the top is greater than the bottom.
This when the top greater than the bottom, you have no HA, right? When the top equal to the bottom, like this, if you have the same thing, the same degree, then
A over B.
yeah, it's going to be the coefficient, the leading coefficient. So A over B. And when the top less than the bottom,
0.
y equal to 0. Okay? So to answer the question from Omar, there can be different number, right? There can be any number. For example, what is the HA for this one?
Because he didn't understand.
Okay, what is the HA for this one? Huh? Isabel? 1 over 2. Why 1 over 2? What is the HA for this one? You look at the highest power, right? The highest power is 8 and 8. So because they are the same, then you're going to look at the coefficient, their coefficients. So you only have 7 over 14, which is 1 over 2. Very good, right? So that's also answer my question, like there can be any line, right? And now I forgot what is the J question. Does that answer your question too? Like you asked me what is the HA, right? Is that? Did I answer your question? Kind of? Hopefully. Okay. So it's, literally you only have two cases. Yeah? When two cases. The one I give you not yeah. I think I meant I want to give you something like this. Not the one I give you earlier. Like this. X over.
Oh.
X over X squared minus 1. Yeah, do you see there's an HA, but they cross it, right? HA is here, but they cross it.
Mister, that HA is 0?
Yeah, but they cross it as well. Okay. So let's talk about a fourth response question. If we have, then we have time. We're gonna move to the next lesson. You think if I give you the test one more time, you know how to do it? No, you need to learn how to do it. How many of you working on the test correction already? Are you finished almost?
Didn't we finish?
Almost? Alright, take that out, take that out. We're gonna work on the free response question. So you need to know how to do it. Take the unit test out.
Mister, do you have one? Because
Huh?
I think I left mine at home.
You forgot?
Literally good. 89.92.
We'll go that time.
What is that?
It sounded like a dead cat.
You okay? Yes. Huh? Oh, integration by part? That's very good one. I think next chapter or something. Yeah, we can do that one next chapter. Okay, the first question asking you about the rate of change. Easy, right? What you gonna do? Oh, I think we're still here, right? Derivative of parametric equations. what is the parametric equation? You remember? T, right? You're gonna call another parameter T to represent x and y. So, huh?
Yes.
It's the lesson for 3D.
No. Then we have to ask. You said there didn't be. We're gonna have another one, or
The one we done before, should we have another T? No, it's still T. Still T. Yeah. Three, not 4.
Yes. I'll practice that. He's like, possessed children. Or a video of parametric. So
Okay, so first derivative. You need to find a dy over dx, right? How do you find dy over dx? If you know that x is some function about t and y is some function about t, how do you find it? How do you find dy over dx if you know that x and y are functions of t?
you get rid of the
You don't get rid of it. Nope, you don't.
You want to using the
Are you gonna change its variable?
yeah? What is it called?
I forgot.
The row.
The what rule?
Y to equals x.
Oh, wait.
What rule you gonna use?
It's like when you change the variable.
Yeah. What's it called?
I forgot.
Something rule. Something. What rule is that?
Don't look at me.
You're like, oh, I don't.
No, because I saw it in.
It's chain rule. No, it's a chain rule.
What?
You know that x is a function of t, y is a function of t. X and y is not related, but you want to find what is the dy over dx. You're gonna using the chain rule.
Oh.
What is dy? You from y and t, you can you find dy over dt? Yeah, can you? They give you a function of t.
Yeah.
Can you find dy over dt? Yes, from here, right? You can find from here. And then from the function of the x, can you find the dx over dt?
Yes.
What happened to the dt? They
Cancel.
cancel out. That's the chain rule. Exactly the chain rule. So that's how you find dx over dt, dy over dx. Yeah? So basically, you want to find the derivative of the y divided by the derivative of the x. Okay? So derivative of the y divided by the derivative of the x in terms of the t. What if I ask you to find the second derivative?
Oh, it's dy.
Yeah, so you're gonna take this one twice. So you're gonna take d differentiated of this one, dy over dx, everything over dx, right? Some notation going on, but I hope you understand it. So that means this y, d square of y and d square of x. Because you're taking second derivative. Or to be precise, it's going to be here. This way here. Because I move the dx down, so I have this one. Okay? Differentiated of dy is d square of y. But dx times dx is dx square. How you find it then? Same thing. I'm going to replace this one over here. Because that's the dy over dx, right? dy over dx equal to this. I'm going to replace this one over here. So I have d of y prime of t over d of dx times x prime of t. So I replace this whole thing here. Okay?
30 steps.
So what about the square?
So it's where the x and x prime is square. Yeah. You know, let me write in a way you can see it. That's one is hard to see, right? So you're gonna have d over dt. Where it go? Until you erase it. Over dx dt. Yeah.
Wait, mister. Why when you're taking the y, when you're taking the y, you square
What did you say?
the d, but then when you take the x, you're squaring the x.
From here to here or from here to here?
From there to there. Like
From here to here? Oh, because now you differentiate a dy again, so that become this y square. This square y, because you take in second derivative. But this one you have dx times dx, right? You gotta bring this one down, right? So dx over dx is dx squared.
no.
This is just a notation. You don't even need to understand it. You want to see how it works. Yeah.
For that one, can you just cancel out the dt and dt on the
Yeah, that's how we got it. That's how we got this one. That's right. So you want to cancel dt, and that's how you got this one. So this one, and you go this one first, and you go this one. But you got it.
Wait, what?
Right.
Because you don't understand this, so I write one more time on this one. Yeah. How about third derivative?
Oh my god.
You want to have a headache?
You have like an hour. You're good.
Okay, good.
Nah, I mean, never mind. You have like 30 minutes.
I think more than 30 minutes.
Now you got like 45. Let's say like 45.
You want to find this one, right? So you're gonna take the derivative. It's just notation, why? So you don't worry if you don't get this one, because they're not gonna ask you how to write in notation. You need to know, you need to understand what does it mean. I will show you what does it mean. Okay? Literally, you just need to take the derivative. To be consistent with this. So second, okay, let me go over again. Second derivative is the square, right? You're taking the second derivative. But remember the current chain rule. After you're taking the second derivative of this one, you need to divide it by the derivative of x again. We will do a sample, you will understand what I mean. Okay? So third derivative is you're gonna take the third derivative from here, like usually, but then you also need to divide it by the derivative of the x again. So that's the point, okay? We do a sample. You will understand what does it mean. Okay? Is it getting harder?
Yes, it was always hard mistake.
It's always hard. How you survive on the AB?
Because they're easy. It's so easy. Because we did nothing. We didn't learn college board.
We watched Bluey. That was like the
I
funniest
tell you,
thing.
I studied at least like 95% of the units by myself, like the months before.
Before the night? Before the test? The night before the test?
No.
You passed, right?
I would have passed if like.
You passed, right? You passed, right? You all passed?
Right.
Right?
The class.
Oh, passed the class.
I passed in my grade.
Oh yeah, I got like 101 in my classes.
Like I thought I had it and I couldn't have it actually.
I remember walking out of 8 by shit, and everyone was like, I'm so fucked. I'm so fucked.
Like all those days, it was like in the closet.
So a curve is defined by this x and y, okay? Show that the curve has two tangent lines. Ooh, in what situation you have two tangent lines? Have you ever seen any graph that have two tangent lines? Very weird, right? You have seen only a curve and then you have one tangent line. In what situation you have two tangent lines? Even if you have multiple curves.
There's only one.
Wait, that's not a big function. But anyway. Like in what case? You get in there though.
If it's like reflected.
Isabel? Was it linear? Oh no, linear you only have tangent line for linear. Linear is Linear is only about the slope. In what case?
Is it when it's reflected?
Reflect? Like you have like this? But even reflect at one point only, right? At one point only, they still have only one tangent line. Parabola, what point you gonna have two tangent line? Circle, they also still have only one tangent line.
What
for every point.
That's a lot. Wait.
No. 2 tangent line at 1 point.
Oh.
I'm talking about 1 point. Yeah. Yeah, there are infinitely many tangent line, but at 1 point you have 2 tangent line. That's the thing. In what situation? Yeah. No, but what kind of graph you're gonna see 2 tangent line at 1 point?
When it's going different directions.
Huh? Absolute value is like this,
I've seen
right?
I've seen
They actually don't have tangent line.
When it's
Huh?
going
Polar is like this. Polar is we're talking about circle. You get in there, but can you tell more specific about what kind of conic section? What kind of like graph is this? 2 tangent line happen when the graph crosses itself. Yeah? Is that what you have in mind? Yeah? So for example, if you have something like this, I'm gonna make it up something. Yeah? This point right here, they cross themselves, they cross itself. So if you look at this line, let me do 2 different colors. At 1 point, I have 2 different lines. See that? This line and this line, right? So 1 point here, I have 2 tangent lines. One is this, and one is this. So that happens when you have 2 tangent lines. So maybe you can take the note. That's something you learned today. 2 tangent line. 2 tangent line is when the graph, when the curve crosses. Yeah, let's do when the curve crosses itself. So 2 branches, let's do 2 branches. They have its own tangent line.
I'm joking. What's the first letter? Oh.
When the curve crosses itself, so 2 branches, let's say 2 branches, okay, have its own tangent line. Yeah. Polar, you need to understand polar is to differentiate between Cartesian and then the card shape, right? So when we do parametric, that's when we have polar. So polar is correct, but what kind of polar is that? You need to be more specific, like this, or this one also polar. Polar is just a name. Polar is also this, right? This is also polar. Circle is also polar. Yeah. So they're all polar. They're all polar. So you can have many tangent line, right? For example, if you have the graph, I just drew it. It's here. You can have how many? A lot, right? Maybe 8, right? Like when it cross itself, how many times? Then you have how many tangent line? Okay. When we're talking about tangent line, write a tangent line. What information do you need to know? That's right. Okay. So write a tangent line. The 2 things you need to know. First is slope. You always need to write a slope. Tangent line is a linear, so you need to have a slope. What is the second thing you need to know? The point. Wow, good. That's it. 2 things only. The slope and the point.
I wasn't guessing anything.
The slope and the point. How do we find the slope? Slope comes from derivative. Very good. So that's why I introduced you the derivative of parametric equation, because that's what we're going to do today. Okay? How do we find dy over dx? That's the slope of the tangent. How do we find it? The one that we just wrote a note is y prime t over x prime t, right? Now, what is the y? Y is here. Now take the derivative in with respect to t. What do you have? 3t square minus 3. Now take the derivative of x in terms of with respect to t. The bottom is 2t. Right? That's the first derivative. Yeah, that's the main point for today's lesson. Easy, right? Just take the derivative. That's it. But how do you apply into the applications? So now, what else? So we found a closed slope already, right? We need to plug it in the point anyway. What is the point they want you to find? So we done the slope. What about the point? What the point they want you to find? 3, 0. That means x is at 3, 0. That means x is 3 and y is 0. So what you gonna do? What do you start from here?
Did you plug it back into the original?
You're gonna plug it in. Very good. Look at this one. X equal to t squared, and I know that x equal to 3. So what about I'm gonna plug it in x equal to 3 here. So I have t equal to t squared, right? And what else? I have t squared minus 3t equal to 0. Let's solve them. Okay? 3t squared equal to 3. That means t equal to t squared equal to 3. That means t equal to 9. What? T is 9?
Plus minus scale over 3.
That's it?
Oh,
You go the other way around, yeah. So t equals to plus minus square root of 3. Very good. That's why you have two tangent lines, okay? If you solve this, let's solve this one. t minus 3 equal to 0. So now you have t equal to 0 and t equal to 3. Right. Can you rate this?
Wait.
Yeah.
Why'd you put t squared when it's t?
Oh, t cube, my bad. The t cube, right?
Yeah.
T cube, so you have t and then t squared minus 3. Oh, so one of them now I send. One of them is 0 and one of them is still plus minus square root of 3. Yes. That's right. Thank you for catching that. But when you solve this, what happened to the t equal to 0? When you plug in t equal to 0, what is the x then? X is 0. It's not 3. Right? So you don't take this value. Because this one means x equal to 0, and which is not the one we want. Okay? So actually they give you the same thing. Square root of 3 and negative square root of 3. Okay, then what are you gonna think? What do you think we're gonna do? You have two lines, right? Yeah, Jake?
Oh, I was just ask a question. You know, we can use that one, the t equals to 0. Is that what she's called the extra solution? I forgot.
Extraneous solution, yeah. Kind of, yes.
So we get rid of it.
You don't check this one.
I like that.
Yeah, that's good. Yeah. What else? Okay, so we have two lines, right? So line number one, let's do t equal to square root of 3. Okay, so what are you going to do next? You know the slope. You know the point. What you going to do? Point slope, that's right. Y minus y1 equal to mx minus x1. What is the slope? Oh, let's write the slope here. What is the slope then? You're gonna plug this one in, right? You're gonna plug in t into this one, right? Okay, never mind, it's right here. So slope here, so you can see it. It's 3t squared, so 3. Plug this one in, square root of 3 squared, minus 3 over 2 times square root of 3. Remember, you have two different slopes because you have two different tangent lines, okay? So square root of 3 and square become
3.
3. 3 times 3 is
9.
9 minus 3, and this one just 2 square root of 3. 9 minus 3 is
6.
6. 6 over 2 is 3 over 3 over square root of 3. Or you can write 3 square root of 3 over 3. Oh, that means square root of 3. That's the slope. I rationalize it. Next time I give you something like this and you work on the ball with your partner. Okay, right? We're gonna do that one.
You don't have a partner.
So sad. Feel so lonely. Now I'm depressed. Okay, you got the slope, you got the point. Now you can write. Yeah, question.
Where'd you get that 3 when you were solving?
This one? This one? This one?
Yeah.
Oh, I multiply both numbers by square root of 3. Rationalize it. I rationalize it. Yeah, it's not constant game because only one term, but I rationalize it. Remember how we learned it in the hem?
But is it okay if it was like
You multiply the same thing because square root of 3 times square root of 3 is 3.
Oh.
Right? Rationalize means you don't want any radical in the bottom. Yeah.
so the answer can't be 3 over 3?
It's a they try to minimize the radical on the bottom. Yeah. So then this one cancel again and then you have this.
So we get incorrect if we left it like 3 over square root of 3.
I don't know about I think just to be safe do this one. I don't know about it depends on the radar. Sometimes they give, sometimes they don't. I don't know. That's the guideline to score it, but I don't know. But to be safe, do this one. Y minus y1. What is y1? What is the point? 0. Very good. What is the slope? Slope is square root of 3. So square root of 3. X minus 3. Y equal to square root of 3x minus 3 square root of 3. That's your first line. Yeah? Now line 2. T equal to what? T equal to? You still know what's going on, right? I lost you already? Since when? From here?
We could just plug in the negative square root.
Yeah, right? Very? You wanna try? Tell me.
No, I was gonna tell you the same thing. Negative square.
Negative square root of 3, right? Can you find a slope for me then? Does it matter vertical line test? No. So this one you cannot using y equal to function of x. You cannot write this because they're not even a function. But actually they are a function. But they are a function of 3 things. Like this is the, let's say this is the when t equal to 0, when t equal to 1, when t equal to 2, when t equal to 3. Like GPS, right? As sometimes you have different places. So you have 3 things you need to do. One is the time, and one is the longitude and latitude. So that's why you have 3 things: t, x, and y. X and y is the coordinate, the position, and this is about the time when it happened. So t here represent, you can think about it represent the t. The time represent the time. T represent the time, and x, y it represents some positions.
Seems like right now we're gonna say that it's for our equation it's gonna be plus negative square root of 3.
So maybe square root 3 is right here at this time and at this time. Right? Oh, okay. So to represent specifically for this question, I think the graph is going to be like this. Okay, this is the point that happened. So this is the point 30. Okay, this is the point 30. That's they have 2 tangent line right here. And then one of them, if you look at the time, they start from here. Then this point is negative square root of 3. But after they go one round, they go this round. That's how they go this round, right? They go this round. They come back exactly the same point. But now the time is already square root of 3. So one point but represent 2 things. Yeah? Did you hear what I just explained? That's a really good question. Did you hear it? No, huh? Let me ask you again if you understand it. Why this is 3, 0? Only 1 point. But why do you have 2 different t? Why you have 2 different t?
Is it because the first one is negative square root of 3, that's the one that's going inside. And
Mhm.
then the t equals square root 3 is the one that's
Right.
technically ending in.
Yeah, only one point, but you have two different times. They happen twice because let's see, you go this way first. Oh, you hit this. That is the time is negative square root 3, and then you go more, and you go back to that time. But that time is different already, right? You go back to that point, but the time is now is square root 3. Do you think like this? Okay, like you pass same point twice. So even though the same spot, but they have two different times. Make sense? Very good question. Find the point on the curve. Okay. Find a point, maybe this is the last one, or maybe continue next time.
No, I don't feel it.
Find a point on the curve where there is a horizontal tangent line. Okay, when the horizontal is a tangent, when the tangent line is a horizontal, what does it mean? What's zero? What do you mean zero? Right, but in this case, we don't call velocity, we call the yeah. But what is zero? The slope is zero. Slope is zero. Keep that in mind. Slope is zero. So how did you find slope is zero? This is very easy. Did we find the slope already? What is the function of slope? Can you give me the function of slope again? 3t squared something?
Yeah, 3t squared minus 3.
Minus 3
Yeah.
over 2t. Right? Okay. Now you're gonna let this one equal to 0 and you solve for it. That's it. Right? Easy? Let's solve it. Let's solve it. If you let this one equal to 0, what happened? That means
Zero.
no. How?
That means there is a nice horizontal edge.
When the fraction is 0, that means the top or bottom 0.
When the bottom is 0.
Top.
No, the top.
That means this one, you only need this one to be 0, right? Because 0 divide anything is still 0, right? So now I'm going to solve this. So 3t squared equal to 3, right? I add 3 both sides. And then divided by equal to 1, so t equal to plus minus 1. Okay? That means, what does that mean? What does it mean when you see plus and minus 1? You need to understand what's going on. That means there are two lines that have 0 slope, right? Horizontal means slope is 0. Vertical, that means slope is all gone. You have 4 types of slope. In HAM, I taught you this, right? Positive slope, negative slope, 0 slope. What does it look like? Horizontal and vertical. What does it mean? Undefined slope. Undefined. Okay. Vertical undefined. So if I ask you to find the vertical tangent line, that means you're gonna find the value so that the whole thing here is undefined. Where? You can see immediately. Where is it undefined?
Plus minus 1.
0. The bottom 0 is undefined, right?
Oh, yeah.
Plus minus 1, gonna make this one become 0. That's mean the horizontal slope, okay? So, what point then? What point? What point is that going to happen? What point then?
1 and 0.
When t equal to 1? But is that your answer? My point is that your answer? No. What do you need to do? Huh? No, you only solve them when they are equal to 0 already. But what is your final answer to the problem? You need to find a point, right? You need to find a point x, y. How do you find x and y? You want to plug in t equal to 1 into the y and t equal to 1 into the x. X is t squared, right? So that's mean equal to 1 squared equal to 1. Y equal to 3t t cubed. Is that t cubed? So t cubed minus 3t. Okay. Okay, first, okay, let's go start from over. They're asking for the horizontal tangent line. And horizontal means the slope is 0, right? Yeah? So we found the slope already in the part A. We found this one is a slope function, right? So now if I want this whole thing to be 0, that means the top needs to be 0, right? So when I solve them, I'm gonna find two numbers that make this whole thing become 0. That is t equal to 1 and t equal to -1. But that is not my answer because they're asking for what? They're asking to find a point, right? So now I'm gonna plug in t equal to 1 into the function they gave you, x equal to t squared, y equal to t cubed minus 3t to find what is the point. Because that's what they're asking you, right? They didn't ask for the t. Yeah, good. So when I plug in 1, I have 1 minus 3, I have -2. So my first point is 1 and -2. My second point is t equal to -1. X is still 1, right? Because -1 squared is still 1. Y is -1 cubed minus 3 times -1. So that's -1 plus 4. So it becomes 3. So my second point is 1 and 3. 3, right? -1 plus 4. So let me just show you a picture. And that we have part C and D, but we're gonna save for the next time, okay? But I'm gonna show you a picture so you can visualize what happened.
Did we
Yeah.
write that part again?
This one? Yeah.
Yeah.
This one or this one?
That one.
This one.
Yeah.
So now I'm gonna plug in t equal to -1 because they have two of them. Plus minus 1, right? So t squared, I plug in -1. -1 squared is 1. And then I'm gonna plug in -1 into here. So I have t -1 cubed minus 3 times -1, right? -1 cubed is still -1 because this is odd. -3 times -1 is, oh, that's why you confused, yes. It's plus 3. -3 minus 1, right? That's why you're asking, that's good. Okay, this is 2 then. 1 and 2. Thank you. So okay, here. Can I have your attention again? Everybody? So now you understand what's going on, okay? Not just like you memorize the way to do it. I want you to understand. This is the graph. Why do I put this one? Is that the one we have been working on? It actually yes, but it is after you eliminate the t. We didn't do that. This is the Cartesian, okay? I did by myself, so that I can show you in here. So when you eliminate the t, you still remember how to eliminate it? Yeah? Lesson 3C. Eliminate the t so that you only have x and y. So after you do that, you're gonna have this one. Okay? The function is this. The one that we have been talking is this. Which point is the point that have two tangent line? 3, 0. This one right here. See that? So the first one you pass it. This is -3. The time. I'm talking about the time. And then they go one round, go back here. This is the time √3. Right? That makes sense. Two tangent line right here. Now the part 2 is where they have the horizontal tangent line. Where is it? When they are horizontal line, where is it? Tell me where to stop. Right? This is one line. What's another one? See? So they're asking you which point on the graph so that the tangent line is a horizontal. So the tangent line is going to changing along the curve, but only here they're going to be 0, right? And when? When is this 1 -2? We just solve it, right? And then another one is 1 and 2. We just solve it. So you understand what's going on, right?
Mister,
Yeah.
Didn't we get 3?
No, it's this one.
I'm changing it. This is 2. Yeah. Make sense? Okay, square root of 3 over 2. Where is it? This is the cosine, this is the sine, right? Where is the square root of 3 over 2? Right here. This is when? 30, 45, 60, right? So sine of 60. You can use calculator. Sine -1 of square root 3 over 2. They're gonna give you the degree. Okay? They're gonna give you pi over 3. Huh? Sine -1 because you will inverse. Sine of 60 is square root 3 over 2. So sine inverse of square root 3 over 2 is 60. You just use your calculator. Use calculator. You see the second, the sign in negative 1 here, sign inverse here. That is how you find back the degree. Okay. So this is pi over 3. So t equal to pi over 3. What else? Is that the only one? Is that the only one? No. You also have over here, right? This one also gives you square root of 3 over 2, right? So what is this?
That's
Pi minus pi over 3. Right? So pi minus pi over 3, which is 2 pi over 3. So you have pi over 3, 2 pi over 3. So far so good? Yeah. The copy for you so you can see. Is it correct? Yeah. But they keep going. They keep going to what? Plus kb. Let's k pi. K of 2 pi, right? They go 1 over pi. 2 pi plus 2 pi plus k 2 pi. Did you know this one? K 2 pi. That means every time they go one circle, they go back, right? So okay, pi over 3 is this. 2 pi over 3 is this. But then when you go 130, 2 pi is the 2 pi is 360 degree, right? So you go from here, you go 200 degrees, you go back here, right? That also gives you square root of 3 over 2. So every time you go 2 pi, they go back to 1 equal to 1. So you need to plus k of 2 pi. Plus k or 2 pi k, whatever. 2 pi k. Okay. And then t equal to yeah, well, just like here. You said it. You can look at the recording because we have only 4 minutes. How do I get t? Divided by 2, right? So the pi over 6, pi over 3 plus pi k. Right? That's one of the solution. Okay? That is for the x. Now you need to solve for the y.
Can we review this at the beginning
Huh?
on Monday? Could we review this on the beginning?
Yeah, we're gonna review on Monday. Okay? So we want to solve y equal to 1. So 2 sine t equal to 1. I feel that we need to like review the whole unit circle, whole trick again.
Yeah, I missed it.
Yeah, okay, we're gonna do that on Monday then. Because if you're not good at the trick, you're not gonna understand what's going
Oh,
on.
Mister, why don't we do it on Friday so we learn about this?
Or tomorrow?
Yeah.
Tomorrow, okay, tomorrow.